In this video, we are going to discuss about Avl tree deletion. So already we know what is an Avl tree and how to do an insertion in the Avl tree. So this video focuses on the deletion, how we are going to perform deletion in the Avl tree. So like the deletion actually happens like your binary search tree. We already know what is binary search tree, right? So like there are three cases when you want to delete a node in a binary search tree. Like when you have a tree structure like this, some random tree structure like this in a binary search tree I'm speaking. There are three cases for deletion, something like this. Okay, so first case is when you want to delete a node with no children. When you want to delete a node with no child, something like this, you can directly remove this place. Okay, so that happens with deletion of a node with a single child, or when you want to delete a node with one child, then replace the child instead of the node. For example, when you want to delete this node has one child. So when you want to delete this node, what we have to do, we have to remove this and add this over here. Okay, so these two are the easy cases. And the next step is deletion of a node with two children. Since binary tree will have maximum of two children, not more than that. When you want to delete a node with two children, then what we have to do, for example, when you want to delete the root node, I want to find the maximum value over here or the minimum value over here, and we have to replace the value with the root node and delete this node, called the procedure for deletion of this node again. Okay, so that is how a binary search tree works, and we are going to follow the same procedure so that you'll understand it better. So with that, we'll be deleting all the nodes. Like we'll be, after each and every deletion, we are going to check the balance factor. And you know what, like how does the balance factor actually look like? The balance factor for each and every node should be either -1, 0, or 1. So this is the category. So we directly call for deletion and we delete the node. After deletion, we calculate the balance factor for each and every node. And if there is any imbalance, like if there is anything that is more, a node which has more than 1 or less than 1 balance factor, we have to rotate it, make the rotation appropriately. Like we have to identify which kind of rotation is needed for that place, and we have to perform the rotation accordingly. Okay, so this is how deletion works, and I have taken some few of the examples which show some of the categories. First, when I want to delete 40 from this tree structure. Okay, so 40 is a node that doesn't have any child at all. Okay, so this is a deletion of a node with no child. How will you delete? We can directly remove this from the given tree structure. We can directly remove it. So this is how a deletion for a node with no child will occur. We can directly remove it. Okay, so after deletion, what we have to do, we have to find the balance factor for each and every node. All the leaf node, the balance factor will take it as 0. And for this node, you have a left subtree of height 1, no right subtree. So it is 1. And for this node, left subtree height is 2, and there is no right subtree. So the balance factor is 2. And for 80, it is 0. And for 110, left subtree, there is no left subtree. And for right subtree, the balance factor height is 1. So it is 0 minus 1. And for 100, the height of left subtree is 2. The height of right subtree is 2. So it is 2 minus 2, 0. Balance factor is 0. And for 50, what is the height of left subtree? You have to take the longest branch that reaches to the leaf node. And you have to count the number of edges. It is 1, 2, 3. And here also you have to take the longest branch and count the number of edges. 1, 2, 3. 3 minus 3 is 0. Okay, so other than this place, all the places, the balance factor is either 0, -1, or 1. So this is the place where you have two balance factors. So we have to perform a rotation over this side. From the node where the imbalance occurs, we have to perform a rotation. Okay, so that is how it happens. And what kind of rotation is needed for this place? It is 2, 1, and 0. So it is the balancing. Imbalance occurred to the left to left. Okay, so we need to perform an LL rotation. How we perform an LL rotation? So this has to be performed. 30 and 10 will remain as it is, and we'll be pulling down this 35 over this side. Okay, so updated tree structure will look like this: 50, 30, 10, 35, and over the side we have everything: 100, 80, 70, 90, 110 and 140. Okay, so after deleting 40, so this is the structure of a tree. And now calculate the balance factor for each and every node in this tree. It is all 0 for leaf node. And for this node, no left subtree, right subtree with the height of 1. So it is 0 minus 1 is minus 1. And for 80, one left subtree, height of left subtree is 1, height of right subtree is 1. So it is 1 minus 1, 0. For 30 is also similar cases. And for 50, what happened? In the right subtree, the height is 2. And in the right subtree, height is 3. So it is 2 minus 3, it is minus 1. Okay, so done. Now 40 deleted, and we have performed rotation to balance the height of it. Now the next node to be deleted is 110. So 40 is a node that doesn't have any child at all. Now consider this 110. When I want to delete this 110, 110 has one child, that is 140. So what we have to do, we have to replace 110 by 140 and delete this 140. Okay, so I'll just do it here. So all these nodes will be deleted or removed. And 140 will be attached here. Okay, so this 110 is removed and 140 will be replaced instead of 110. Now calculate the balance factor. If there is any imbalance, now we have to perform a rotation for it. So all these things will remain as it is. For 100, what happened? The height of left subtree is 2 and height of right subtree is 1. It is 2 minus 1 is 1. And for 50, the height of left subtree is 1, 2, height of right subtree is 1, 2, 3. So 2 minus 3 is minus 1. So everything remains as it is. And the balance factors are there either as 0 or 1 or minus 1. So it is a perfect height balance tree. So no need to do it again, anything. So the next node to be deleted is 140. So 140 is a node that doesn't have any child at all. So what we do when you want to delete a node without any child, we can directly remove it from the tree structure. So now this is the resultant tree. I'll draw it again. You'll have 50 here, 30, 10, 35, 100, 80, 70, and 90. Okay, so now I'll check the balance factor for these nodes. For all the leaf node, balance factor will be 0. For 80, height of left subtree is 1, height of right subtree is 1. 1 minus 1 is 0. And for 30, height of left subtree is 1, height of right subtree is 1, it is 0. And for 100, what happened? What is the height of left subtree? It is 1, 2. And what is the height of left subtree? There is no left subtree over here. Sorry, right subtree over here. So it is 2 minus. It is 2 minus 0. It is 2. And 450, what is the balance factor? Height of left subtree is 1, 2. And height of right subtree is 1, 2, 3. So 2 minus 3 is minus 1. So we have an imbalance occurred in this place. And what kind of imbalance is this? There is no right subtree at all. So it is left subtree. So the rotation that is needed is ELL rotation, and we have to perform it over here. Okay. So how we perform an LL rotation? You have to perform it like this. So 80 will remain as it is. 70 will be its left child as it is. And 100 will be pulled down as the right child for 80. And where come this 90 is attached? 100 will not have any left child, so we'll be attaching it as left child for 100. Okay, so this is how an LL rotation actually occurs. So this 80, 70 will remain as it is, and we'll pull this 100 down. And while pulling this 100 down, this 90 will be attached to this place. And when you check the property of your binary search tree, it's satisfied. 80, 70 is less than 80, and it is there in the left subtree. And 100 is greater than 80, so it lies in the right side. And 90 is greater than 80, lesser than 100. So it comes as the it is there in right side of 80, but attached as left child for 90. Sorry, 100. Okay, so this is the overall structure. Now I'll update it over here after rotation. You'll have 50 here and 30, 10, 35. And here we have performed the rotation 80, 70, 100 and 90. So calculate the balance factor for each and every node. For all the leaf nodes, it's 0, 0, 0, 0. And 400, height of left subtree is 1, no right subtree. So it is 1. For 80, height of right subtree, left subtree is 1, height of right subtree is 1, 1. 1 plus 1 is 2. So it is 1 minus 2 is minus 1. And for 30, it is 1 minus 1. And for 50, height of left subtree is 2 minus height of right subtree. Take the longest branch that reaches the leaf node and calculate the number of edges. 1, 2, 3. It is 2 minus 3 is minus 1. So all the nodes are balanced over here. Okay. So next step is to delete the number 50 out of it. The node 50 has to be deleted. So 50 is a node that has 2 children. What we do when you want to delete a node with 2 children, there are 2 possibilities. One is take the highest value in left hand side or take the lowest value in right hand side. Okay, and you have to replace that with the 50. So 50 will be replaced. I go with this side. Okay, I will go with this left hand side. I take the highest value over here. So the highest value in this side is 35. So I replace 50 with 35 and I call the procedure for deleting 35. Okay, so the procedure will be repeated again. Now what happened? 35 is a node with no children. So we can directly remove it. Okay, so this is after deletion. So after deletion, the tree structure will look like, draw it here, 35 as the root node, 30, and you'll have 10 here. And this node will be deleted. And here you have 80, 70, 100, and 90. Okay, so now calculate the balance factor for each and every node. For all the leaf node, it is 0. And for this node, 100, the balance factor is 1. And for 80, it is minus 1. And here for 30, what is the balance factor? 1 left subtree, no right subtree, it is 1. For 35, the height of left subtree is 2, height of right subtree is 3. 2 minus 3 is minus 1. Okay, so now again call the procedure. I'll delete 70 here. Okay. So in this, I'll be deleting 70 of my next node. So what happened if I want to delete 70? 70 is a node that has no child, so we can directly delete it. The tree structure will look like this. We'll have 35, 30, 10, 80, 100, 90. Okay, 70 can be removed as it is. Now calculate the balance factor. All the leaf node will have 0, and here it has 1 left subtree. So it is 1. And here for this node, 1 left subtree. There is no right subtree. The height is 1 minus 0. And for 80, there is no left subtree. But for right side, the height of the right subtree is 2. 1 minus 2 is minus 2. And for 35, over here you have 2 nodes, and over here you have 3. So it is 2 minus 3. 2 minus 3 is minus 1. So this is the balancing factor, and you have an imbalance occur over here. And what kind of imbalance is this? For 80 is the place where the imbalance occur, and the balance factor is minus 2. So on the right side, we have an imbalance, and over here it is in L. So it is RL rotation need to be performed. And how you perform an RL rotation? It is a 2-step process, right? So first we perform between these 2 nodes. So it is connected as 80, 90, and 100. So we are going to bring that into RR pattern and perform an anti-clockwise rotation in this. So 90, 100 will remain as it is, and 80 will be brought down. Okay, so now I'll show you. Okay, so the final tree structure for this will look like, we'll have 35, 30, 10 as it is. And here in this case, you'll have 90, 80, and 100. Okay, so this is after the deletion of node 70 from this tree structure. Now calculate the balancing factor here. So here it is 0, here it is 0, 0. And for this node, 1, height of left subtree is 1, height of right subtree is 1. So it is 1 minus 1, 0. And for 30, height of left subtree is 1 and height of right subtree is 0. So it is 1. And for 35, it is 0. All then perfect. Now I want to delete the node 35. When I want to delete node 35, how can I do it? So 35 is a node that has 2 children. How come we can delete a node with 2 children? Find the lowest value over here or find the greatest value over here. I prefer this side always. So now I'm going to take the greatest value over the side. So the greatest value over the side is 30. So replace 35 with 30 and call the procedure for deleting 30. Okay. So now when I want to delete 30, 30 is a node with single child. How will you delete a node with single child? You replace 30 with 10 and we delete this 10. So the overall structure for this will look like this: 30 as the root node, and instead of 30 we have replaced 30 with 10, and this side will be having all the nodes as it is: 80, 100. Now calculate the balance factor for each and every node in this place. All the leaf nodes will have 0, and for 90, height of left subtree is 1, height of right subtree is 1. 1 minus 1 is 0. And for 30, height of left subtree is 1 and height of right subtree is 2. So it is 1 minus 2, it is minus 1. So it is perfectly balanced Avl tree. So this is how a deletion is performed. So when you want to delete a node, we have to verify whether the node that we are going to delete has a 0 child or a 1 child or 2 child, and call the procedure for deletion. After deletion, we have to check the balance factor. And when there is an imbalance occurred, you have to check which kind of rotation is actually needed, perform the rotation. So after performing rotation, check for the balance factor again. Okay, so this is how an Avl tree works. So I have covered all the topics regarding how does the Avl tree works, what are all the different types of Avl tree or rotations, and how to insert a node in the Avl tree, and how to delete a node in the Avl tree. Thank you.